Welcome to our study in integration. Today we look at the reverse process of differentiation, which is simply integration. And integration is the process of finding the integral. So let's look at differentiation to begin with. Let's have our equation y is equal to x squared, and let's also have y is equal to x squared plus 4. So these two equations are different. However, if I get dy dx of this one, I have 2x, and if I get dy dx of this other equation, I equally have 2x. I have the same dy dx, but coming from different equations. Having said that, let's look at integration. So integration, you integrate an equation of the form, say we have y is equal to x to the power n, ax to the power n. Then the integral of ax to the power n is simply you adding 1 to the power to get a new power, then dividing that new power, dividing everything by the new power. So if we're going to have the integral of 2x dx, then we would have 2x, the power here is 1, so we're adding 1 to 1 over what we have there, which is 1 plus 1. So we are going to have 2x squared over 2, which will give us x squared, giving us what we have here. Now notice that this is giving us the same equation. However, these two y's are different. Hence the need we add a constant all the time when you're doing your integration, just in case your first equation had a constant in it. You have x squared plus 4, having the same derivative but coming from different equations. So if we're saying integration takes us back to our earlier equation, then there is need for us to take care of the constant, just in case the equation had a constant. So every time you integrate, you add plus c. Our c here is 0, our c here is 4. Hope that's clear. Let's have an example. So integrate 3x to the power 4 plus 4x minus to the power minus 3 with respect to x. So we want to find the integral, that's the sign of integration, the integral of 3x to the power 4 plus 4x to the power minus 3 with respect to x. So we have dx there. So remember, we're going to integrate term by term. So we have the first term here, we have 3x to the power 4 plus 1. We add 1 to the power, then we divide everything by the new power which we have, which is a 4 plus 1. Plus, again we have the next term, which is x to the power minus 3. We add 1 to the power, we divide everything by the new power, which is minus 3 plus 1. Then we have our constant. So this will simplify to 3x, 4 plus 1 is just 5 over 5, plus we have 4x minus 3 minus 1 will give us minus 2 over minus 2. We have plus c. Don't forget your constant all the time. This is just 3x to the power 5 over 5. Negative into positive will be a minus, and 2 into 4 is 2x to the power minus 2 plus c. You would have found would have integrated that equation given. Then for our second example, we have the integral of 6x squared minus 5 with respect to x. So we're going to have 6x. We add 1 to the power, we're going to have 3 over 3 minus what we have here is 5. But then 5 is the same as you having 5x to the power 0, because anything else to the power 0 is 1. So then we're going to have 5x 0 plus 1 is just 1. In the power 1 is as good as you having nothing. We'll put it there for now, over the new power, which is 1, plus c. And this will be 3 into 6 is 2x to the power 3 minus 5x plus c. So all the time you're getting you're integrating a constant. It's just that constant times x. It's with respect to x. So the integral of 5 is 5x. The integral of 2 is 2x. The integral of 1 is x, like that. So you don't always have to show the 0 and adding the 1 to the 0. So that will be the integral of our second example. And for our final example, we have the integral of, so we have fractions here, 1 over x to the power 4. So what we have is the integral of x to the power 1 over 4 minus. So remember what we're doing when we're differentiating fractions of this sort. You push the x with its power on top, but changing that the power has a negative sign now. So you bring the 1 on top, you leave it as it is, it's just 1, so it's as good as you don't write it again. So you bring the x to the power 4 on top and introducing a negative on your power. This is the same as that which you have on top there, dx. So then we're going to have x, we are adding 1. So we add 1 to this one, we're going to have 5 over 4. Then we divide by the new power, so divided by 5 over 4 minus, we have x, the power, we add 1 to the power, you're going to have minus 3 over minus 3 plus c, which is equal to, so whenever we have double fractions like we have here, I always encourage my students to separate them like this. I have x to the power 5 over 4 divided by, because this is what this means, divided by 5 over 4. Negative into negative is positive, so now we have plus x to the power minus 3 over 3 plus c. Then this is x 5 over 4. You change the sign, you swap or reciprocate this one to be 4 over 5 plus x minus 3 over 3 plus c. So this is just 4 over 5 x to the power 5 over 4 plus x to the power negative 3 over 3 plus c as your integral of the other of this equation given here. Thank you.